Alright, this is question 1.1.3 on the June 2021 exam question paper, and it is a quadratic inequality, everyone's favorite. It's not everyone's favorite, but it's doable. You just have to remember the different steps and make sure you do them correctly. That's what we're gonna do here. First of all, remember that it is still a quadratic form. Most times it's going to be a quadratic form. That means you know your right hand side has to be 0, you have to factorize and all those things, right? So that's what we're going to do first. I'm going to move the 9 here because I don't like it, that 9. We're just going to take it to the left hand side and make all of that make the right hand side be 0. So that means we're going to have x minus 1 squared minus 9 is greater than 0, right? That's a great start. And then now we are going to simplify, expand this, have both the copies, minus 9 greater than 0, x squared minus x plus 1 minus 9 greater than 0. Add the like terms, minus 2x here, minus 1 is minus 2x, and then 1 minus 9 is minus 8 greater than 0, and this is where we're going to factorize it, right? We're going to factorize it and solve for x when this whole expression here is equal to 0. That is called finding the critical values, right? We're going to find the critical values of that yellow expression there. So to do that, I'm going to say critical values, CV for critical values, and we're going to say x squared minus 2x minus 8 is equals to 0, right? What this means, it's asking, yes, I understand. You're asking me for the values of x where this expression is bigger than 0. But I want to understand first what happens when the expression is exactly equal to 0, right? And we know this. We've solved this before. You just open two brackets, equate to 0, put your x there, and then the two numbers here are going to be 4 and 2. 4, 2. The signs are different because the C term or the 8 is negative, and then the bigger term is going to be negative because the middle term is negative. So we have x equals to 4 or x equals to negative 2. We are not done. We were finding the critical values, and we're going to use these critical values to find our final answer. I'm going to go here. We're going to use the critical values to find our answers. So I'm going to use the graphing method to answer these questions, mainly because I think it makes more sense, right? And it's quick. You're just going to have your straight line here. You're going to put your critical values first. I'm going to put negative 2, and then I'm going to put 4 here because we're going from the smallest to the biggest terms. And then I'm going to draw a quadratic a graph. It's just a simple graph because I want to understand the nature of the values after 4 and in between 4 and negative 2, and then before negative 2. So because this term here is positive, right? Because our term here, the coefficient of x squared is positive, this whole thing is going to be a graph that is looking up. It's going to be a smiley face. A nice smiley face. Now, look at this. Here, going to use this color here, that's at a 0. That means this line here is 0. The whole red line, we are at 0. And everything that is above 0, everything that is above 0 is positive, right? And everything that's below 0 is negative, right? So what are they asking us? What is this question asking us? If we go back to here, just here, they were asking us, what are the x values which will make this thing what? Greater than 0. And greater than 0 is what? Is positive. In other words, in this small graph that we drew here, they want to know the parts, or they are just interested in the parts that are positive. So from here, all of this is positive, right? From here, all of this is positive. So you can see that if I start from 4, if I start here and I move that way, the graph is going to be positive. And if I start on -2 and move this way, the graph is going to be positive, and that's what they are looking for. So in other words, our first answer is whenever x is greater than 4, the graph is going to be positive. And whenever x is smaller than a -2, the graph is going to be positive. Those are your two answers to this inequality question.